All right, everyone. So on our first activity today, second activity today, sorry, we're going to be talking about scale. And scale is really important because we do it wrong all the time. And it causes a lot of misconceptions in the kids because what they see and experience, whether it's in videos or photos, books, and whatnot, is always wrong. There's a reason for it to be wrong, but it's always wrong, and it gives them the wrong impression, and so they build off of that. That repetition hundreds of times of seeing something the wrong way, it's hard for them to kind of visualize it the correct way. So we see things like this, a simple model of the solar system, and yes, we've lost a couple of planets here, unfortunately, but the example is correct in that none of this is right. The size of our planets is wrong, and the distance between our planets, you can see a little bit better, is horrendously wrong. Both of them are just terrible. But we still put them that way so the kids can see kind of what's going on. That these items are in this order and that they're all in our solar system. But we do kids a disservice when we don't talk about the reality of these models and how flawed they can be. So, one of the things we need to talk about is when kids have misconceptions, you can tell them this is the right way. You're wrong and this is the right way. And they will nod their heads, and they might even get the answer correct on the test if it's pretty close to when you told them this. But they will often revert back to their base knowledge, which is incorrect. You have to use different activities. You have to prove to them. They have to prove to themselves, more importantly. If you follow a constructivist model of how knowledge is built, they need to see this is wrong. They need to then take new information and kind of pack it in and say, okay, this is the better way to approach that. So you just telling them isn't going to do the trick. You have to be able to get them to experience this. Oh, this is wrong. Now let's go search for the right answer. Okay. As an example of that, for instance, this basketball and this tennis ball are approximately the right size for the Earth and for the Moon, roughly in terms of shape, obviously, volume. So if you give them to this and you say, okay, kids, how far apart are these? They look at the pictures and they see them like this. Okay, so there's the Earth and the moon's orbiting, yay! Except this is completely wrong. They do this so they can fit the picture into a book, into a video, into the size they have, but it is not accurate. This is also, it gives kids a false impression of phases of the moon because they'll see the Earth, they'll see the moon, they go, oh, clearly it's the shadow of the Earth on the moon, and that's why it's causing phases. And it's partly because they see it this way, this close. Okay, this correct distance should be about 30 feet between this and this. That would be more accurate than this. Okay, so you take this, give it to your one kid, and then hold the ball, and then walk away, and then you tell the kids when to stop, and they'll say it's here, and they'll say here. Some will even say a few feet away, and then you just keep walking until you get all the way across the classroom, and then you say, no, this is the correct way. And not only that, but the moon doesn't go around in a flat orbit. The moon is tilted. It has an axis to its orbit, so it's going up like this, and then around, and then down. And that's also part of the reason why kids think the shadow of the Earth is affecting the phases of the moon, because they think of it as a flat disk, which is the way we always draw it. Okay? And then, of course, there's reasons why the moon's off axis compared to the Earth, but we can get into that a little bit later. But anyway, so modeling scale, true scale, is really important for some of these kids to develop a better understanding of the fundamentals of how our solar system is put together. So to help us with that, I have a piece of register tape, just 1 meter long, okay? 1 meter long. There it is, blank. And you have the kids write on one side Pluto, on the other side the sun. And then you say, okay, put in the planets. And they get out their pencils, and then they start writing, and they go, okay, done. And so they put the sun on one end, Mercury, Venus, Earth, Mars. A couple of them put in the asteroid belt, yay. And then you get Jupiter, Saturn, Uranus. They start running out of room. They squeeze in Neptune, and then Pluto's at the end. And they're like, okay, there's my setup. Most of the planets equally distant from Sun to Pluto. And yes, of course, you can have a discussion about Pluto's not really a planet, it's a dwarf planet, but the math works better to have Pluto in there. And it's still there, so we can count it. All right, so this is fine. It's horribly wrong, but it's fine. Now, so what you do then is you have your kids flip this paper over. And you say, okay, now write the sun on one side again, write this Pluto on the other, or give them a new one. If they wrote in marker, give them a new one. If they wrote in pencil, you can use the other side. And then you start saying, give me some instructions. The instructions for this are in your packet. I'm not going to go through every detail because it's going to take too long. But basically, you start folding this. And that's nice. Fortunately for us, the math works pretty well. So you fold it in half, for instance. And you say, and you need to take the time to ask as you go. If you just steamroll through this and have the kids do this, 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 and this, and they don't question themselves as they do this, you are gutting the heart out of this activity because you're not getting the kids to get what's called cognitive dissonance, what they think is supposed to happen compared to what actually happens. And if they don't wonder about it, they're not learning it as well. So you say, okay, halfway, Pluto's on one side, sun's on the other, what's in the middle? So they go through your list, and you put the list right up on the wall. What planet's in the middle? Wow, gosh, it's either Mars or Jupiter, one of those two. So they'll say, okay, it's Jupiter. And you're like, okay, great, Jupiter goes right here, right here in the middle, and it's like, no, you're wrong. The middle is actually Uranus. Okay? And they're already freaking out. So there's Pluto, Uranus is in the middle, and you say, okay, so you fold it in half, and you're going to fold it in half again. So now you've got quarters, and of course this is a great time to go over fractions. Now you've got quarters, so you've got the sun on one side, you've got Pluto on the other, you've got Uranus in the middle. What's this going to be? Well, there's only one planet between Uranus and Pluto, so that should be pretty easy. That should be Neptune. And then when you say, okay, so what's down here? I've got half my solar system left. What could this possibly be? And they're going to say, oh, Mars, or maybe Earth. No, they're wrong. It's Saturn. Saturn goes down here in the quarter gray mark, okay? So at every step, you've got to get them to think, and they'll be wrong every way because they think the solar system is evenly distributed, and it's just not. So the way it works is we start with Pluto at the very end, quarter mark, or I guess 3/4 mark from the end. We have Neptune. Halfway we have Uranus. 1/4 we have Saturn. Now, you're going to fold this like this to get an 8th. And at the 8th mark, that's where Jupiter goes. And the kids are flipping out because it's like you've got 4 planets to squeeze in here and you only have this tiny little bit left. And then you fold it again, so now you have a 16th. And guess what? That's not even a planet. That's the asteroid belt. So then you fold it again, and now you have a 32nd, and then that's Mars. And then you fold it in half and fold it in half again, this tiny little space, and you can't even write these numbers or these planets down, Earth, Venus, Mercury. This is the correct scale. So Earth, Venus, and Mercury take up this much space. Asteroid belt, Jupiter, right? This is the scale. And at this scale, you then ask them, how big is the sun? And they'll be like, oh yeah, the sun's this big. And well, at this scale, the sun is the size of a grain of sand. That's how big it is. So a correct size, correct distance. The sun is a grain of sand, and every planet is microscopic. And that's the correct scale.